Hello, everyone. So here I am with another chapter in Python programming, and it's called Data Frames in Python Pandas. I've already introduced you to the module called Pandas when we started with the topic called data series. And there we learned that this Pandas module is basically used for data analysis. And there are two main important data structures present in the Pandas module. One was the data series, the other one being data frame. We've covered the data series in the previous videos, okay? So today we're going to be starting with the data structure called data frame. Now, when you compare a series with a data frame, we've already seen it even before in the previous chapter. A data series looks like a one-dimensional array, whereas a data frame looks like a two-dimensional array. So in this video, I'm going to introduce you to a data frame. I'm also going to be telling you how to create a data frame using a list as well as using a series. So let's get started. So now what's a data frame? I said it's a two-dimensional figure, okay? When you say two-dimensional, it definitely consists of rows and columns. The easiest to imagine a data frame is a table in your MySQL. So when you have a table in MySQL, it is also a two-dimensional structure where you have rows and columns. You can imagine your data frame to be completely identical to it. Okay, now what are the various characteristics of a data frame? Now, characteristics of a data frame, when I talk about this, I would also, compare it to data series. So it becomes easy for you to understand. A data series would only consist of one column and all the elements of the column of the same kind. Here, since you could have many columns, okay, each of those columns could be of a different type. That means if you have a column called roll number, it could be talking about integers. If you have a column called name, it could be talking about strings and so on. Okay. Secondly, the size of the data frame is mutable. What do I mean by that? Suppose your data frame currently consists of 2 rows and 5 columns. It could become 7 rows and maybe say 8 columns, or it could even reduce. So the size, the number of rows and columns of your data frame can be increased or decreased, mutable, can be changed. Values are also mutable. That means anything inside the data frame you want to change, you can do so. Okay, and it has two accesses because it's a two-dimensional structure. So it has axis 0 and axis 1, and these accesses are labeled. Now, do they have another name? In data frame, do we use, what do we call axis 0 and what do we call axis 1? I will come to it soon. And you can perform, any arithmetic operation on the rows and columns of your data frame. Clear? Okay, now this is the structure of a data frame. Now, when you look at it, isn't the MySQL table the first thing that comes to your mind? That's exactly what I said. You can imagine a data frame to look like a MySQL table. Now, here you need to be understanding certain things. Now, what are the things that I want you to concentrate on? Can you see it has a heading? That's just like your column headings, like you have column names in MySQL, and it has a label here as well. Okay, now these are rows, right? 0th row, first row, second row. These rows are called index. They're on axis 0 and they are called index. And this 0, 1, 2, 3, they're called index labels. Now, these are the default index labels, okay? You could be giving them, named index labels also. Whereas what you see on the top, they're called columns or axis 1. And the student ID, student name, class, address that you see are all called column names. So all of them constitute or make up the columns, whereas each of them is a column name. And whatever you see within the structure is the data or the value. Now, can you see that in some places I have written NaN? We know what NaN stands for. NaN stands for absence of a value or not a number. So if you do not have a value in a certain column at a certain location, then that is going to be represented by NaN. So missing values are going to be represented by NaN. Is that clear? So I hope you got a rough idea of how a data frame looks, okay? And it's, I told you, it's so similar to what do you say, a MySQL table, but you need to know that the rows are called index and the columns are called columns. Is that clear? Okay, let's get ahead. Now, how do you create a data frame? Now, you can be creating a data frame using collection data types or using data sets. Now, what do you mean by collection data type? Your list, your series, your NumPy arrays, your dictionaries, your ND arrays. I mean, that's your NumPy array. All these are coming under the category called collections, okay? Collection of elements. So you can create a data frame using any of these collections. There's something new that we're going to learn here is we can also create a data frame either from a CSV file, even from a text file, or from a SQL table. Okay, so we can create data frames using either of these elements. Okay, so we're going to start with how to create a data frame. The syntax for creating a data frame is, please pay attention, pd.data frame. First of all, what is PD? PD is another name for your Pandas module. Okay, you have to import the Pandas module if you have to make use of the functionalities of the module. Data frame, D capital, F capital, is the name of the function that helps me to create a data frame. Okay, now I want you to look at this part very carefully. What does data mean? How are you creating the data frame? What are you using to create a data frame? Are you using a list or a dictionary or a series or a NumPy array? That is what your data will represent. How is the data frame created? Is that clear? Okay, so first let's learn how to create an empty data frame. To create an empty data frame, I write pd.dataframe and I do not provide any, any parameter. So no data is provided. So what does that mean? That you have created an empty data frame. Now you might think after creating an empty data frame, what? I have told you the size, the row, the columns and the rows are mutable. After creating an empty data frame, you could add rows, you could add columns, up to you. Okay, so if I say print the data frame, I would get something like this. It would say it's an empty data frame. There are no columns, so otherwise they would specify the names of your columns there, and there are no indexes as well. Okay, let's learn how to create a data frame using a list. Okay, now for that, I want you to keep a track of this. This particular line, okay, is what? Is nothing but a list, correct? What's a list? A list is a collection of elements, okay, that is enclosed within square brackets. So can you see many names enclosed within square bracket? So names variable in my program is a list. Okay, I am using the function called data frame, that is pd.dataframe, and I am providing names, which means I am providing a list. So the data that I'm providing to create the data frame is a list, and that is the reason, see the heading, it says creating a data frame using a list. Okay, now what does this list consist of? Pooja as one element, Rohan as another element, Amit as a third element, and Kriti as the fourth element. So what happens when you create a data frame using a list? When you create a data frame using a list, every element of your list becomes one row of your data frame. So if I say to show me the output, this is what you're going to see. Can you see Pooja, Rohan, Amit, Kriti? They're all elements of your data, of your list named names. So every element of your list becomes one row of your data frame. Now, can you see by default the index is coming as 0, 1, 2, 3 because there are 4 rows? And can you see the column coming as 0 because there is only one column? If there were more columns, as you see in the examples ahead, you will notice that your column numbering will also go 0, 1, 2, 3. Now these are all the default numbering, correct? Is there any way I can change the index, or is there any way I can change the column names, is what we are going to be looking at next. Okay, so let me take you to the next screen. Again, remember, I am creating a data frame using a list. Why am I saying that? Okay, look at this carefully. The variable named as student, that's nothing but a list. So if you look at the data frame function, I have passed student as a parameter, which is a list, which means what? Again, I am trying to create a data frame using a list. But now I don't want the column heading to be 0. I said columns is equal to names. Now here I wrote columns is equal to, and I give only one heading, because we just saw if I have a Pooja, Rohan, Amit and Kriti, getting created into a data frame, I'm just going to be getting one column. So if I'm going to get only one column, I would need to have only one column name. Okay. So how do we go about with the output, or how does the output look? The output looks something like this. So when you compare it to the previous output, your column heading was 0 because that's the default, indexing or the positional indexing. Whereas here, since you specified the column had to be names, you got the heading as names. The next example talks about how your index labels can change. So again, you have student, which is a list. You're using a function named as data frame. Okay, what are you passing to the data frame? Student, which means you're still creating a data frame using a list. Column, I want names as the heading. And index, because I have 4 students, my indexes, instead of being 0, 1, 2, and 3, is student 1, student 2, student 3, and student 4. So the output looks something like this. Okay, but remember one thing, even though you give names to columns or to indexes, the default numbering still continues to remain. Okay. Now, here also I'm creating a data frame using a list, but I want you to understand the small difference here. Okay, now I have a list. This is a list. This is a list. This is a list. And this is a list, correct? And each list is giving me a name and some number, maybe their percentage, maybe their roll number or whatever. Okay, now look at this function. I said data frame. Can you see a square bracket here? Which means basically I am providing a list to the function called data frame. And what did I say? When you provide a list to create a data frame, every element of the list becomes one row. Okay. Here, the first element of the list is student 1, which itself is a list. That is why, the comment statement there says creating a data frame from a list of list. Okay, so student 1, that's Pooja and 86, will become one row of your table or of your data frame. Similarly, you have student 2, student 3, and student 4. So you are creating a data frame consisting of 4 rows because you have 4 list elements, but each element is also a list which consists of 2 elements. So now in this scenario, my data frame will consist of 4 rows, but it will consist of 2 columns. Okay, how does the output look? Let's look at it. Can you see? It consisted of 4 rows, but along with that, it consisted of 2 columns. Now, since you did not specify the index label, and since you did not specify the column label, it continued with the default value. But like I said, you could have suggested the column labels as name and percentage, or name as roll number, whatever, by using the parameter called columns, like we have seen before. And you could specify the index labels by using the parameter called index. Is that clear? Okay, so we are here also creating a data frame using a list. The only difference is this is a list consisting of a list, or you could say a nested list. But remember one thing very important. Every element of the list that you provide to the function called data frame, every element becomes one row of your data frame. Okay, now look at this example. When you look at this example, look at class 11. Okay, the variable called class 11. What is it? Now, how do you know what is it? Look at the brackets used, curly brackets. Curly brackets means what? Class 11 is a dictionary. Okay, what about this? This is class 12. Again, I can see curly brackets. So what does that mean? This is also a dictionary. Okay. Does that mean that I'm creating a data frame using a dictionary? No. Look at the next line. You are using the function called data frame. But can you see the square bracket again as a parameter? Which means your parameter is a list. But the list contains a dictionary. That is what I mean by list of dictionary. But remember again, I am using a list. But the list, instead of containing another list like the previous example, here each list element is a dictionary. So what did I say? Class 11 will become one row. Class 12 will become another row. Every element of the list will become one row. But there is a slight twist here. Twist is whenever you use a dictionary, to create a data frame, the keys of the dictionary, because remember the dictionary consists of keys as well as values. The keys of the dictionary automatically become the columns of your data frame. So your columns are not going to be numbered as 0, 1, 2, 3. Instead, they would be singing, dancing, drawing, and elocution. So these 4, so that means the unique, the unique keys of both your, dictionaries. Now, you could have had many more dictionaries in the list. That doesn't matter. Every element of the list, that means class 11 is a dictionary, but it's the first element of the list. So it consists of the first row. Class 12 becomes the second row, and so on. To have a look at the output. Okay. Now, can you see on the first row under elocution, you see NaN? NaN is a missing value. Why do we see that there is, if you look at it carefully, does the class 11 dictionary consist of a key named elocution? No. So a value is missing for a heading called elocution. And that's the reason it's NaN. Similarly, in class 12 dictionary, you don't have a value for dancing and drawing. Therefore, it shows NaN. Is that clear? So the difference is that if you have a dictionary involved, the keys of the dictionary automatically become the columns of your data frame. Okay, let's go ahead. Now, creating a data frame from a series. A series is somewhat similar to a list, right? Contains elements, but we said a series is homogeneous. Every element is going to be treated as the same type. So here also the concept is going to be the same. Here, if I look carefully, S is the series. Can you see? How do you create a series, guys? PD dot series, correct? So I am creating, in this example, this is a series. Okay, I'm creating a series. The name of my series is S. I'm creating a data frame using S. So that means what is S? A series. So that's why I'm not using a list here. I'm using a series. Okay, so my data frame is created using a series. Series behaves like a list. So what do you expect to see? I expect to see Jitendra, Purnima, Arpit, and Jyoti on 4 different rows. row numbered as 0, 1, 2, 3 and column numbered as 0 because I did not give any column label or any row label. Okay, so let's look at the output. The output looks just identical to how it would look like in a list. Okay, now if you remember the series chapter, we had learned that there was a way of giving a name to a series, and I said the advantage of giving a name to the series you will realize when I create a data frame using a series. So let me come to this. This is your series. Now look at this. So the name of your series is S. When I say S dot name, so remember this has nothing to do with your data frame yet. I'm talking about the series logic. S dot name means the name parameter of the series S is given as author. So that means I'm just trying to say that Jitendra, Purnima, Arpit and Jyoti are all authors. Okay, then I am creating a data frame using a series. Now when I'm creating a data frame using a series, obviously every element of the series is going to become one row. But what happens to the indexing, the index and the columns is what I want you to look at. Because you did not specify the index labels continue to remain 0, 1, 2, 3. I did not specify the column labels either, but the column label has become author because your series has a name. So the name of the series automatically becomes the column name in the data frame. Now, could I achieve this using, the columns property also? Yes, I could have achieved it using the columns property also. I could say, pd.dataframe s, comma, columns is equal to, and in square bracket and in quotes, write author. So even if the series did not have a name, it will get the name that you have specified. Is that clear? Okay. Now, when I'm creating a series, do you want to, give an index? You could give an index. That means instead of 0, 1, 2, 3, what would you see? You would say index is equal to student 1, student 2, student 3, and so on. Now, why has the column label come back to zeros? Because here the name of my variable for the series is author. And that's just a variable name. I did not give a name to the series. Okay, neither did I use the columns property. If I used the columns property here, if I wrote comma, okay, before closing this, and columns is equal to, and you say what you want the column heading to be, then instead of 0, you would see author. Is that clear? So you could get a heading if the series has a name, or you specify the column names. Okay, so I hope creation of a data frame using a list and a series is clear, both similar. Every element of the series or every element of the list is one row of your data frame. Okay, so in the next video, we will learn how to create a data frame using a dictionary and a NumPy array. Okay, bye. See you in the next video.